These are the Electron batteries. These are 72 volt, 22 amp hour packs. They are made for us in Asia, as almost everything else is these days, but quite a high quality pack. It's using Samsung cells, and it has a 60 amp battery management system, which handles charging and discharge. And we have here our charge port, which are the smaller cables, and our discharge port, which is a spark resistant XT90 plug. And the batteries go in a specific order. You need to put the rear battery in first because the space to put them into the fuselage is here, and then they slide back. As well, we want the cable exit point to be facing up, to be on the upper side of the battery. And the reason for this is the battery management system is on this side of the battery as well, and therefore we want to provide it with as little impact. If it was on the bottom, then impacts, although it is padded on the bottom here with foam, there would be some weight and some impact. Better to have their battery management system and sitting on top as well. This way it can dissipate any heat in the BMS system better. So we'll slide this back battery in and then the front. So that's our rear battery in place. Now I'll put the front battery in place. Now these batteries, I should say, are identical, and that's quite important because when you're drawing power from and charging into a pair of batteries, you want them to have the same resistance and the same typical current flow. So these batteries are basically self-balancing. And let's put that front one in. Something to note here, this is the main circuit breaker, and it is currently in the off position. And always ideal before you connect battery power to make sure that your circuit breaker is in the off position, and then when you're actually ready to charge the system, we'll turn it on. We won't do that for some time. So I'm plugging the batteries into the harness now. As well, I'm plugging the battery charge points into the charging harness. This is our charge port here. Okay, and now that both batteries are in place, I will slide the rear battery forward as far as I can, because that distributes as much weight to the front of the bike as possible. The reality is, with the rider weight being on the back of the bike and the heaviest component in the bike being the rear wheel, we want to do everything we can to keep that weight forward. So having the batteries as far forward as possible really helps. Now the batteries are held in place by 1.5 or 1 inch actually Velcro straps. And we found this to be entirely adequate because they are quite well nestled inside the fuselage, and there's really no reason for them to move around much anyway. And we found these straps to be adequate to holding the battery down. But you do want them to be good and tight. And once we're done installing all of the other electrical components and wiring, then there are a number of cable ties that will go into place to hold all of the wiring in place. But we're not at that stage. All right, so we have our batteries in place. We have our high voltage harness in place. Now I'm going to start installing some of the low voltage signal wires. There's quite a few of these things, and for the benefit of future Electron buyers, I'll describe them as they go in. Okay, so this guy, this is our cycle analyst to controller splitter. Because we're controlling two e-bike controllers with one cycle analyst computer, there's a splitter that sends the signal to both, and the splitter that is labeled with the red band goes to the rear controller, because that is the master controller, the one that is sending signal like the speed up to the cycle analyst. So the rear red banded one goes to the rear, the non-banded goes to the front controller, and then this passes up to the cycle analyst. It's in the cowling, and this part here goes into the control box that will be part of the Footwell harness. These are Joulette cables. This is the splitter that takes the two signals from both brake levers and combines it to one to send forward to the cycle analyst. And on its way to the cycle analyst, it passes through the control box, which allows that signal to be sent to both the cycle analyst as well as to the brake lights via a relay. This little bundle of wires is the signal control that comes from the hand switch that manages your turn signals and your horn. And this will pass forward through into the control box as well. And we want to make sure that we leave the right amount of slack so that there's room for the handlebars to turn fully forward and fully backward. All right, that's looking good. And I'll install some split loom now just to keep this bundle of wires together. And also in this bundle is the brake hose that's coming from the front brake. And in the other bundle on the other side, we will find the brake hose that is coming from the rear brake. And then this set of wires is our signal set, and it's written right on it. It says Tailbox lights. So this is the wire that sends the signals from the controller box back to the tailbox to manage the brake lights and the turn signals, as well as the running lights. And we'll put the label up front. And we want all of these cables to be roughly the same length, because they will all pass into the same control box. And there we have it. So at the back of the bike, we have the auxiliary battery input port, which allows us to run additional batteries in the tailbox. And we have the tailbox turn signals and control switch and such. And then we have the power for the rear motor. This is our charge port. And then up at the front of the bike in this giant bundle, we have all of our signals and control wires that are passing into the control box, as well as our power for the control box and our signals that are going forward and up to the cycle analyst, which is what I'll be installing next after I install the various other parts that are going on. Okay, so here we are. We're going to continue on with the assembly of the Electrom. And as I go, I'm going to tell you about a few of the parts that are going on. So let's start out. We're going to put on the front footwell, which goes up here and will provide a place for the cowling, as well as hide all of these wires and provide some weather protection. As I go, I'm going to tell you about each of these components. So this is the Electrom footwell. It is made from carbon fiber, Kevlar, and fiberglass, as well as epoxy resin. And these are our turn signal lights. We have our lifter strut mounts for the canopy, and as well, this is the adjustment point that allows you to set the height of the canopy. And the footwell goes on fairly simply. Okay, so the tools required to install the footwell, fairly simple. We need our Loctite. Almost every bolt and nut on the Electrom has been Loctited or thread locked. And by the way, all of the bolts and nuts on the Electrom are stainless steel. This is quite important. It's an all-weather vehicle. We know it's going to get exposed to moisture. Therefore, all bolts and nuts stainless steel. All hinges are stainless as well. Wherever possible, we've used aluminum and stainless almost entirely on the bike. I don't know really of any straight steel components. I guess the cogs on the teeth for the chain wheel are steel because they need to be to handle that kind of stress. But other than that, it's all stainless steel or aluminum. So the footwell goes on with 3 5mm Torx bolts, and I will apply Loctite into each of the holes. Because the Electrom endures a lot of vibration, Loctite is quite important. And this is kind of the standard on all bicycles. Now, kind of obvious, but I'll just say it anyway. In order to get the footwell up onto the fork and the frame, the front wheel and the fender have to be off. So if you ever need to take your footwell off on your bike, you will need to remove the front wheel and the fender. And it's a bit snug going past the top of the fork crowns. There we go. And we always want to make sure any of wires are up and where we want them to be. Just rest that there for a moment. We've used torque bolts wherever possible, torque head bolts wherever possible, or I guess they're called Torx, because they offer a better grip and it decreases the chances of somebody tampering with your bike. Lots of people carry Allen keys and maybe will unbolt a part or two here and there, but the Torx standard is a little less common and therefore provides a little bit more security. All right. Those are now in place. It's starting to look a little bit more like an Electrom. Next up, it's time to mount. Okay, now it's time to mount the control box. So this is probably the most complex electrical part of the Electrom, and to be honest with you, it's not terribly complex. This is the control box through which the various control signals pass. So that is the signals from your brake levers and the signal from your turn signal switches pass through this box and are interpreted and sent on to the cycle analyst, as well as there's a relay in here which takes the brake signal and splits it out between your rear brake lights and pass it up to the cycle analyst in order that it can know that the brakes have been applied. So we have the back of the control box where all of the signals come in, and the front where the signals come back out. As well, there are specific connections, and I've taken great pains to make sure that basically the majority of these connections are unique to where they want to go, so there's only one place, which is the correct place, where you would attach them. Okay, our signal box is in place, and now it's just a question of connecting the various connections. This part now is the cowling and fairing adjustment, and it's fairly straightforward. We've got a bolt, a spacer, passes through the frame. This is adjustable because by moving the footwell fore and aft, or backwards and forwards, you can raise or lower the height of the cowling for different size riders. Actually, it was a little premature of me to put that in because it's going to be easier to get at the various wires while this is still open. Okay, all of our wiring is in place, and we are ready to install the front cowling. This is the Electrom front cowling, and this is one of the more expensive parts on the bike. This is a polycarbonate vacuum formed component that is carrying both of our headlights, our side marker lights, and in addition to that, we also have our Cycle Analyst V3, which is the computer that controls the whole bike, and our mirrors. A lot of people have asked me, like, well, why do you have that thing? Well, and so the answer is, in addition to providing rain protection for your legs, it's a very convenient place to put your cycle computer and your mirrors in a location where you can see them. Something else I'd like to point out is the back surface of the cowling, the dashboard, so to speak, has a rounded surface and no sharp edges. Everything has either been filed smooth or has a nice soft rubber gasket on it. And the cowling itself, the polycarbonate, is ridged enough to not flop around in the wind, but is soft enough that in the event of a frontal crash, it would probably collapse and not do damage to the human body as we went through it, past it, beyond it, over it, under it, whatever's going to happen. Let's not kid ourselves. Having a head-on collision on a bicycle with a vehicle or an immovable obstacle is never going to be pleasant. But I can say that at least the cowling on the Electrom is not going to be the biggest part of the problem. It will, in fact, perhaps maybe protect you a little bit, although I wouldn't say that. All right, let's put this on and see how it goes on. Okay, that's got the cowling on, and now we're going to apply the lifter struts that will cause it to lift up easily and as well hold it down in place. These guys are pretty simple. These are basically just straight up 80 Newton meter cabinet lifter struts. You can get them from IKEA, you can get them online. This is a replaceable item. They do, because it's a gas-filled strut, they do eventually wear out. Most of the time it takes about 5 years for them to wear out, but for that reason they're a very easily replaced part. And they simply snap in place. We want the head down. Okay. Canopy set. All right, at this point, we have the canopy on. We have all of our wires sorted. These wires will be connected later when the lower footwell cover goes in, because there are switches that these connect into. So we won't do that for now. Okay, so we have the cowling on, we have the front footwell on, all of our wiring is in and all tidied up. So we're ready to carry on. The next thing to do is we're going to install the front fender, and I'll go grab that. The Electrom front fender is another piece of carbon fiber. This is 2 layers of carbon and 2 layers of fiberglass, and a lot of people ask me this, well, why do you have to have a carbon fiber fender? Well, we don't really have to have a carbon fiber fender, but what we did have to do is we had to make our own fender. There was really nothing on the market that I thought was suitable, that did the job we wanted to do, and it had the looks that we were looking for. There's lots of cheap plastic fenders for 20-inch fat tires and stuff, but there was really just nothing that was robust, fit nicely into the fork, had the aerodynamic profile, and actually stopped as much grime from coming up as we wanted. So once you're making a mold and putting the manual labor into hand laying up a part in fiberglass or carbon fiber, well, you might as well go with carbon fiber. So not only does the carbon fiber add a little bit of rigidity, but it has that appearance that people like so much. And as I say, there's so much labor involved in this that another couple of bucks for the cost of the material is really kind of worth it. So in your building process of your Electrom, you want to put your front fender on first and then your wheel. It just makes life a whole lot easier. So I'm going to go ahead and install the front fender now. And the fender has grooves in it that line it up with the slots in the fork so that it fits nicely. And it goes on with zip ties. And I know that might seem a little hokey, but in the end, we tried a lot of different things. And zip ties, these are not just any zip ties. These are high quality UV resistant nylon zip ties. And they're good for like 500 pounds. But in the end, the zip tie is actually kind of the best tool for the job here. I'm not doing them up super tight because I'm going to want to be able to move the fender up and down and adjust it a little bit in order to line it up for the wheel. So next on comes the front wheel. So this is the Electrom front wheel, and let me tell you a little bit about the front wheel on the Electrom. It is a front hub motor. We're using on the bicycle version of the Electrom, we're using the Bafang G311 hub motor, and the reason for this is the G311 has a two-stage planetary gear reduction. It ends up being an 11-to-1 gear reduction, which means that for the maximum 700 watts of power that you can put into this little motor, you get a tremendous amount of torque out. And this is kind of crucial in order for the Electrom to work as a bicycle and legally as an e-bike in most places. It needs to stay below a certain power threshold. And so what the Bafang G311 does for us is it provides a huge amount of torque for relatively low power. And one of the cool things about this motor as well is because it's a geared hub motor, most of geared hub motors are designed to freewheel when not in use so that you're not working against the motor if you're not drawing power. And so with the Electrom, we have a very powerful rear hub motor that supports regenerative braking. And on the front, we have this quite torquey little hub motor that helps us get up to speed and help climb hills. But then once we're over a certain speed, it shuts down to preserve power and maintain the efficiency of the bike. And because it's got that freewheel in it, we're not working against the front hub motor with the rear. So going over this, we're running very, very wide, very beefy BMX rims. These are Stranger Crux XL, which is a very high quality, all aluminum, double wall BMX rim. We've been running these rims for a couple of years now. We have zero problems. And Sapim 13 gauge e-bike specific spokes. And these are hand-built wheels, hand-built by me as a matter of fact, Loctited all the way around. The idea with an e-bike wheel, especially in a spoke deal, but e-bike wheel is a well-built one, doesn't change. I mean, I guess if you hit a massive pothole or a curb, well, there's nothing we can do about that. But with the Loctiting and these really good spokes and this really good rim, this wheel should last a very, very long time. And then we've got a 204 millimeter disc rotor for maximum stopping power on the hydraulic brakes. And then the final thing is every hub motor, especially one going on to a suspension fork, wants a torque arrestor. So this is the Grin torque arrestor made by Grin Technologies out of Vancouver. It's a very nice beefy stainless steel plate, and it is designed specifically for the Bafang G311, so integrates very nicely. So let's go ahead and put that on. Okay, the tools we need for this are an Allen key set and I believe a 17mm wrench. One of the things about installing the hub motors on the Electrom, either front or rear, is it's a lot easier to do if you just take the disc brake off. Because that way you don't have to worry about getting the disc rotor in through the pads at the same time as you're trying to line up the torque arrestor and you're trying to line up the slots. And the thing about these things is that the wheels are quite heavy because they've got motors in them. So they're already a bit of a chore to handle. So anything you can do to make the installation of the wheel easier, it's always a good idea to do it. So I'll remove the disc brake caliper from the fork. And as usual, I'll be careful not to lose my bolts. Okay. Torque arrest faces down. There we go. And then we have this bolt here, which is a bolt, a washer, and a spacer. And we want to not lose track of those because those are going back on. So I'll put them down with my disc brake bolts. Washers go on the outside of the forks, and in it goes. Okay, that was too easy. I'm suspicious. There's got to be something going on here. Well, here's a couple of things I know. Whenever you're installing a hub motor, you really have to work hard to get the hub motor up seated into the dropouts of the fork. Just because it's so heavy, you've got to push it right up there. And you want to make sure it's well seated before you go and line up your disc brake, because what if you put all this effort into lining it all up and then you lower the bike and put weight on the wheel and discover that your wheel's out of alignment? Now you have to realign your disc brake again. So I'm going to use my shin and knee and really apply upward force on this as I tighten these bolts down. And we want these to be pretty snug. If you look up the specs, they'll tell you, I'm not going to tell you right now because I don't know them off the top of my head. But in general, when you're dealing with axle nuts on hub motors, you want them to be quite tight. Not so tight that you strip bolts. If you're an experienced mechanic, you know what that feels like. If not, then get yourself a torque wrench. So, our axle nuts are good and tight. Now I'm going to install our torque arrest clamp, and the spacer goes behind. Bolt in, and I'll tighten that up. And then the final thing to do is to put our disc brake back on. And although I did cover this in the how to change your disc brake pads, I'll just cover again how to line up your disc brake caliper with your newly installed wheel once I get these done up. Now you may notice I'm using a little multi-tool here with a bunch of different Allen keys on it. It's true that proper mechanics tools in some ways are easier, but what I like about these little multi-tools is I can always select the right Allen key size for what I'm working on. And some of the spaces in the Electrom are fairly tight. And so this little multi-tool I particularly like because it has short little stubby Allen keys that allow me to fit the tool into tight spaces. So I'm bringing these bolts just up to snug, but not super tight. I'll come back and give the front brake a good squeeze. That'll help center the caliper on the rotor. Give the wheel a spin. Now we hear that rubbing. That is not actually the disc brake, that's the fender, because I haven't lined up the fender yet. Okay. And we do this by eye and by sound. Next thing I'm going to do is I'm going to attach the power cable to the motor, which connects the motor to the controller. I'm going to hold on to this little guy because it's handy to have these around. And I'll get my fender nice and centered. And that's looking good. So that's our front wheel installed. One of the things I should point out is when you first install new calipers with brand new pads on a rotor, there's typically a bit of a break-in period where it's not going to run perfectly smooth no matter how carefully you line everything up. But after about 10 minutes on the bike, you'll wear down the pads a little bit and they'll seat in nicely. And it will be silent. Something else to point out while we're here, when you're breaking in new disc brakes, it's quite important with new pads you don't want to heat them up instantly and glaze them because that doesn't break them in. So you want to gently break in a new set of pads. Basically, you want to be going down a hill or just cruising along and apply the brakes for a couple of seconds and let them go, let them cool down a bit, apply them again, and then let them go, let them cool down, and just do that a couple of times to wear off a little bit of that fresh surface and break in the pads. But as I said, what you don't want to do is go down a massively steep hill and just hammer on the brakes and get them smoking hot right away, because that's going to glaze your pads before they've had a chance to break in, and then they'll never quite work as well as you'd like them to. Well, they could. You would have to take them off and file them down, and that's a whole other story. So this is starting to look like a bike, isn't it? Okay, what next? Well, let's install the rear wheel. For the rear wheel install, we need two things. We need our Allen key set, and we need a 21 millimeter wrench. The bolts on the wheel we're about to install are 21 millimeters, and so that's what we need here. I'm just going to check the balance here of our bike. It's a little front heavy, but that will change once we put this massive back wheel on. Okay, here is the Electrom back wheel. This is a direct drive hub motor. This is in fact a 9 Continents 212 direct drive hub motor. We found this to be the best combination of reasonable size, good torque, good efficiency, and great regen braking. So the regenerative braking in this, when I'm going down a hill and I go into full regenerative braking, I can put as much as 2,500 watts of power back into my battery and slow the bike right down. Now, part of the reason we can do this is the Electrom is running these 2 batteries, which is actually much more battery than you would need for the power that the Electrom draws, but we want that much battery because we want that really long range, the 200 kilometers, but it's also very handy to have that much battery to dump all of this massive regenerative braking power back into without damaging the battery. So let me tell you a little bit more about the 9 Continents 212. We've preloaded it with Grin Technology Statorade, which is a ferrofluid which is designed to conduct heat from the stator to the outside of the motor, and so that helps it stay cool in hot temperatures and under heavy load. Once again, we're running the Stranger Crux XL rims, and we're running the 204 millimeter disc brakes. It is an L10 connector, which is a nice beefy connector that can handle lots of power. And we're running dual torque arresters on both sides. Now, this is something that may change in a future model, but for now we found this is the best way to manage that regen torque. And then on the other side of the motor, we have a 32 tooth cog that is receiving the small amount of human energy that goes to the back. The reality is that as soon as the Electrom is over about 10 kilometers per hour of speed, then all of your human energy is going into the generator chain drive, like into the generator and producing electricity. But it is very nice to have that ability to use your human torque to help get the Electrom up to speed, as well as to help climb hills. And it's actually quite handy for getting down off of the center stand if you're stuck on a hill, because sometimes these electric hub motors are very powerful, but the controllers we're running are smart controllers, and they're smart enough that if they sense a stall position, they're not going to just keep pouring current in for fear of frying the battery or for fear of frying the motor. So as a result, it's handy to have that human power to just get the bike moving a little bit if you're in a really steep uphill position. The rest of the time, it doesn't matter. It's fine. The motor's got all the power in the world to get us going. So let's go ahead and put this on. And same thing again. It's going to be much easier to do with the rear disc brake removed, and especially on the rear of the bike, because this motor is so heavy. It weighs about 30 pounds all told with the tire and the tube and the rim. So, and I've just taken the spacer out of the disc brake. Don't forget to do that before you do this maneuver. But yeah, this is such a heavy wheel that you really need all the advantages you can get in order to get it up and into place. We'll set it up so that the cable exit is facing back and the torque arresters are facing back. Okay, so we're ready to put the back wheel on. I've moved the camera so you guys can get a better view. Now, there's a couple of things to think about before we go ahead and do this. We've removed the caliper. We're ready to go there. We've got our torque arresters in the right place, and our cable exit that comes out of the axle is exiting out of the back of the axle, facing towards the back of the bike. Now, one of the things we have to be aware of is eventually the chain has to get onto this cog. And so we want to make sure the chain is part of this setup and not on the outside once we get the whole thing bolted together. Otherwise, we got to take it all apart to get the chain into the right place. The chain is here, hanging out, waiting to do its thing. And it's probably one of the more awkward parts of this whole operation because we've got to slip it on. We're not going to try to get it onto the cog in the same operation. I'm just going to try to get it over the axle so that later on I can move it onto the cog. try not to do that. Fortunately, I had just moved my nuts further out, so I didn't damage the threads. Okay, so passing the chain over the axle. Careful not to smack your fingers in there. So now I've got that chain running on the inside of the cog. It's over top of the axle of the wheel, so I don't have to worry about it now. It's in the right place. I move my torque arresters out, and there's some little washers on the inside of the torque arrestor. They want to be between the hub and the frame, so they have to be on the inside. So torque arresters on the outside of the frame dropouts, little washers on the inside. And now, up we go. Oh, and one more thing. There's always something. Before I do this, there's these torque arrest bolts and nuts that want to come off before you try to put this on, because they'll get in the way if you leave them there. And as you can see, I'm working pretty hard at this because this is about a 30-pound wheel here. Okay, here we go. Now, here we go. Well, that's actually going on fairly well. Got to move these washers around. This is something that if you're doing this with a friend, that'll make it much easier. If you're doing it out on the road after fixing a flat, all I can say is it really sucks. Everything about that really sucks. We will cover how to deal with a flat in another video. As you can see, I'm using my knee to hold the wheel up in place. And there we go. So, dropped in on one side and wiggle the torque arrestor, get it to come up on the other. Oh, there we go. There we go. So our wheel is up and in place. Finger tighten, and I'm just going to tighten this one down enough to hold the wheel in place so that I don't have to keep holding it up with my knee. Then tighten this up a little bit. Now, before I go any further, as I said, it's quite hard to get your wheel all the way up into the dropouts when you're dealing with a 30-pound wheel. So the easiest way to manage this is we'll go and lower our stand gently. And then I'm going to push down on the back of the bike to get it down onto the floor and put all my weight on top of it, loosen these guys back off, and now I'll tighten it up because I know with all my weight on this back end that these axles are nice and seated into the dropouts. Okay, so another thing to talk about is the torque arresters. The job of the torque arresters on the Electrom is to stop the axle from twisting back and forth as you switch from braking to acceleration to braking to acceleration. Because with regenerative braking on a hub motor, all of that force, whether it's acceleration force or deceleration force, is going through the axle. And it will wiggle back and forth and slowly loosen off the axle nuts if you don't have torque arresters in place. But even the best torque arresters have a little bit of play. So part of the reason we have two torque arresters is so that we can oppose them against each other. One I will push down so that it's applying counterclockwise force on the axle, and the other I will push up so it's applying clockwise force on the axle, so that by opposing each other, they're holding that axle and stopping it from rotating. So I'll go ahead and insert and this can be a little tricky to get the nut on. Fortunately, on this side, there's actually slots in the cassette, in the cog, that I can use to pass my fingers through. On the other side, it's not so easy. So I need a 10 mil wrench to hold these. No, sorry, it's an 8 millimeter wrench. And here's a little trick for you. To get this nut into this tight space, I'm going to put some tape on the box end of my 8 millimeter wrench. That will hold my nut in place. And I was wrong. It's a 10 millimeter wrench. Okay, so as I said, the next step on this procedure is to install the bolts and nuts that hold our torque arrest up onto the frame. And getting that little nut into that little space in between the frame and the disc brake in this case is a little challenging. So we'll use a trick. The nut is held by a 10 millimeter wrench, and I'm going to put some tape on the wrench to hold the nut. I'll use the box end of the wrench. And we'll just put that tape on the back. Put our nut in, and that tape does a nice job of holding it in place, so that now I can slip in and okay. Okay, that one's snug. But not super tight yet because we haven't done our opposing direction trick yet. Okay, that's good. Now, I'll just use my 21 millimeter wrench and load up some torque on there, and then tighten this down good and tight. And on this side, I'm levering it up, and I'm going to loosen that off just a little bit. Not so much that our axle drops down. And there we go. So what I've done is I've just moved that torque arrestor up forward so that it is applying that kind of pressure, the opposite of what the other torque arrestor is doing. And now I'll tighten these down, and I'll get more tension by using the wrench. So I'll just hold it in place. I'll just hold it in place with the Allen key and use the wrench to tighten. There we go. Then finally, I'm going to really tighten up these axle nuts. These are great, big, beefy, I think they're 12 millimeter hardened steel axles. And these are good, hard steel nuts. So it's very hard to strip them. So don't be afraid to go really tight. So my general rule of thumb, I'm using quite a long handled 21 millimeter wrench. I want to be applying enough pressure that I leave quite the indentation in my palm from the wrench. So that's got our axles good and tight. Now we put our disc brake back on. Of course, I do have this nice motorcycle stand. I could lift this back up to make my life easier, but we'll just go ahead and get this done. And for aligning the disc brake, we loosen off that's looking good. And I'm going to give the rear brake a good squeeze now. And you see how when I squeeze the brake, the disc caliper moves around a little bit because it's moving into place. And with the brake squeezed, I'll give this a good tighten. And that usually will do an adequate job of centering our disc caliper on the rotor. It's pretty good. We've got a bit of rub there, but as I said, that's going to go away in the first 10 minutes of a ride. Collect our tools. Okay, while we're back here, I'm going to do up our motor. There are arrows on the L10 connector that tell you which way to align them. And that's nicely done up. That's all good. And later on, when we go to put our covers on, we will hold this in place with the cover. That's the rear wheels on, front wheels on. It's looking more and more like a bike every day. Okay, let's reset the camera back to the middle of the bike and we'll carry on. All right, we're moving along nicely. Okay, our next step, we've got a number of choices here. We could put the seat on, we could put the tailbox on, or we could put the side panels on. I'm going to go ahead and put the tailbox on and we can talk about that. So this is the Electrom tailbox. Once again, this is made out of carbon fiber, fiberglass, and Kevlar. And we've got our nice heavy-duty stainless steel Nerf bar which is there to both protect the bike when it falls over onto its side, as well as it provides a handy dandy place for a passenger to hold on to. And then the other thing that's quite helpful with this is if you're maneuvering the bike around, like say for example, if you have to walk it from one place to another, you can hold on to this bar in order to manage the bike. So the tailbox, we've got our locking rear, turn signals. This is the signal input wire, so we have to keep track of this. That's going to connect to that wire that's over there. And let's go ahead and put it on. It goes on fairly easily. Basically bring it in from the top. Before we bring it all the way on, let's get these wires. And in fact, what I'll do, because I like to keep track of these guys, is I'm going to tape them in place so that they don't flop around in the future. Okay, so we've got our tailbox signal line, which is the little 5-pin wire here. It's actually a 6-pin, but there are only 5 wires in use. And then we also have our auxiliary power for if we're carrying an extra set of batteries in the tailbox. So this just passes through a hole that has been drilled in the tailbox, and this hole is in a nice protected area, so you don't have to worry about moisture getting into it. Okay. Then we lift the box up, slide it forward. The tailbox will be fastening to either the front or the rear setting. Most people keep it on the rear setting. Unless you're quite a short person, then you might want to move the tailbox forward by the 2 inches in order to have it on the front. But we'll line it up on the rear, and then there's another fastening point on the back of the fin. So the easiest way to do this is lift up a little bit, bring it forward, and then lower it down over, because it's a rather snug fit. And it's aligned when the front of the tailbox is aligned with this aluminum tailpiece. To make my life easy here, I'm going to remove the tailbox lid. Okay, that's it. Our tailbox is in place. Put the lid back on. Right, so we've got the tailbox on. Next up, we're going to install the seat. And let's talk about the Electrom seat. The Electrom seat is another carbon fiber piece, and it's handmade by us here at Electrom. And the reason for this is we tried a lot of other different seats made by different manufacturers, and the reality is nobody makes a seat that's designed to go onto a 6-inch wide aluminum subframe. And so we realized in the end, after trying to adapt and modify other people's recumbent seats, that they neither had the angles we wanted nor the mounting profile we wanted. So we made our own. So the seat is a multi-layer carbon fiber, Kevlar, and fiberglass layup. It is very light, and it has some special properties. It is quite a good angle. It is the right angle. People often get on it and they say right away, wow, this is the most comfortable seat I've ever sat in. And I'm not just saying that, it really happens. We've got a carbon fiber frame that supports a mesh back. The mesh back is quite important because it allows for sweat to breathe through your back because you're exercising on the Electrom, you can't have a car style seat that doesn't breathe properly because you're producing quite a lot of perspiration and that needs to be able to go through. As well, the mesh back is adjustable via 5 straps, so you can add and release tension in different parts of the mesh to tune the seat to your particular torso shape. And we found that this seat fits anyone from about 5 foot up to about 6'2". And to be honest, I haven't tried a 6'4" person, but I'm quite sure it would fit. And then the other part of the seat is the cushion. The cushion is, if I don't drop it, the cushion is a multi-layer, multi-density foam cushion with moisture wicking upholstery surface on the very top that allows for perspiration to wick through. And then we have a nylon, basically a stretchy nylon cover that goes on top so that you can remove it if you need to wash it. Quite simply, the seat cushion just goes in like this. It's not held in place by anything, but it doesn't have any reason to go anywhere, especially with your weight on it. And we have left it that way because one of the handy things about this is if you park your Electrom and it's raining, well, the rest of the Electrom can handle the rain no problem, but you don't want to come back and sit on a wet seat. So what I typically do is I just take the seat off and I toss it in the tailbox. When I come back, I put it back on and I'm ready to go. The seat has adjustment slots, and you can adjust the seat fore and aft by about 2 inches without having to undo any bolts, so you can fine tune it for different riders. And then as well, on the frame, we have 5 bolt mounting points, so the actual amount of distance the seat can move fore and aft is upwards of 10 to 12 inches, and that means it can fit a very wide size of riders. And if you're moving from a very small rider to a very big rider, it does mean you will have to undo 4 bolts and move them into different bolt hole locations, but it's really not that big a deal. It's one of those things where we could have made a really fancy seat slider thing, but that would have added a lot of weight, a lot of complexity, another part that could break, and as well, it would have added cost. The reality is the Electrom is typically going to be ridden by the same person day in, day out, and once you get the seat set up for you, you're going to keep it there. Let's go ahead and install this. You'll see how easy it is. One final part is we have our mounting plate that goes on top of the carbon fiber and takes the pinching force of the bolts and distributes it evenly over the carbon fiber so that we don't have a split. Okay, still have my Allen key in my pocket. The seat is mounted with 6mm stainless steel bolts, and I happen to know that the next person riding this bike will be me, so I'll set it up for my leg length. Pretty straightforward. I'm not going to clamp it all the way down just yet because I'm going to slide it forward. So to adjust the seat, we just loosen off the bolts and we can slide the seat fore and aft by a good number of inches. And as I said before, if you need to make a bigger adjustment, you undo the bolts all the way, move them to different bolt holes, and then tighten it up. So there's where I'm going to need the seat. Okay, that's got it. Seat is in place. And we'll put the pad on. That's good to go. Okay, next up are our swing arm covers. These are mostly aesthetic. They're just cleaning up the look on the back of the bike, but they also do help hide the cable for the rear motor. And on the other side, they help protect the chain. Something I didn't cover actually, the chain on the Electrum is almost entirely shrouded in covering, so that it does not get a lot of contaminants like grit and road grime and moisture on it. And so as a result, the chain stays relatively clean and relatively dry and lasts a very long time. In fact, all of the Electroms on the road are still using their original chains because there's no chain stretch because of the GCD. So the fact is, it's just one of those very low maintenance parts. I lubricate my chain maybe once a year, and that's about it. And these side covers help with that. So they're affixed with 5mm bolts. I like to use the Torx head for these as well, just because it's a nice looking finish. So I'll grab those and we'll go ahead and put them on. And to apply these Torx head 5mm bolts, I am going to use a cordless drill. This really speeds things up, but I should let you all know I have it on its very lowest ratchet setting because I'm driving the stainless steel bolts into relatively soft aluminum. I don't want to strip that aluminum, so this will start ratcheting at a very early stage. Okay. They are side specific. They swoop down in the front and up in the back. And it can be a little bit tricky to line these up because you are hunting for a little hole. But with bolt out of the way, you can see that little hole. There it is. And so there's that ratchet. And before we go any further, let's tuck this cable up and into here. There we go. And hunting for the hole. There it is. Nice and clean. I'll go over to the back and do the back side. All right, so now we've got the swing arm covers on, we've got the tailbox on, we've got the seat on, we're ready to put the side covers on, and this bike's finished. All right, these are the Electrom side covers. They are vacuum formed ABS. It is basically the best material for the job. Looks nice, fairly robust. If you were to break a set of these, they're not super expensive. We could probably do a replacement set for about $300. But the fact is, this type of plastic is pretty strong and should last quite a number of years. The other thing too is it's well supported on the frame, so it doesn't have a lot of reason to break. I've ooched the frame forward onto the side of the motorcycle stand just to make this process a little easier. And once again, I am going to use my cordless drill, but as I said, I have it on a very low ratchet setting so that I don't strip any of these bolts, because once again, they are going into fairly soft aluminum and they're stainless steel. They could strip it really easily. We don't have to do these up super tight. They just have to be tight enough to not have it fall off. Now, we don't have pedals on yet, so that does make life a little bit easier. to apply the side panels, we rotate the crank to the back position, and it's a lot easier on my other bike. We have to bend it a little bit to get it past the crank. There we go. So we made it in past the crank, and there is a slot here, and we bring the bar and the control cables up through. And the other thing on this particular side is we have to get the battery charge port flap through here before we apply it. So I'll pull this away a little bit, pull the battery charge port flap out, pass it through here, pull it out, there we go. So it's on the outside now where we want it, and goes back into its location. So that's looking about right. Grab a couple of our 5mm and when I'm doing this up, because there's a lot of holes and they're hard to line up exactly, I don't do them up all the way tight at first. I get a few in, get all the maneuvering of the piece done. Or no. There are 2 holes on the side panel that require slightly longer number M5s. So we've got them here. These are 10mm long instead of the 8mm. All right, that's good. Now we'll go do the other side. All right, there we go. Well, we have an almost complete Electrum. Unfortunately, I forgot to bring the top cap that goes on here, so we can't put that on for now, but it's certainly rideable without it, so that's good. And there we go.